Okay, so here's a video of some supplemental problems from section 8.5 in geometry. So the whole section works with its angles of elevation and angles of depression, but really it's mostly with working with just word problems basically of triangles and trig. So for number one, that was the one I did of the book. Lenora wants to build the bike ramp shown. Wants to build the bike ramp shown. Find the length of the base of the bike ramp. So the base, okay, is that distance right there. So what we have to basically identify is, hey, I've got the 20-degree angle. Okay, so this is the 20-degree angle I've got. Looking at the drawing, then I have this side across from it, which is the opposite, and then this side here I'm looking for is the adjacent. So for us, I'm looking opposite and adjacent. That's tangent, because tangent is opposite over adjacent. So the tangent of 20 degrees is 10 over, we'll call it b. And to solve for b, multiply both sides by b. b times the tangent of 20 equals 10 divided by the tangent of 20. Okay, and then b equals 10 divided by the tangent of 20. Okay, now that's our exact answer. Again, ACT will take exact answer. Our approximate answer is simply 10 divided by the tangent of 20 degrees. And again, make sure your calculator's mode is in degrees. So that gives us 24.7 or 24.5. Okay, 24.5 feet, by the way. Okay, so there's number one. Number two was the next problem we did out of the book. Okay, now this one is the one that requires us to do a drawing. And let's see here. So a baseball fan is seated in the upper deck of a stadium, 200 feet away from home plate. If the angle of depression to the field is 62 degrees, what is the height the fan is sitting? So basically, I'll do my best to draw this out. Here's our fan. He's sitting up in the upper deck. Okay. He is 200 feet away from home plate. So here's home plate. So he's 200 feet away, okay, from home plate. Now the question is, how high off the ground is he? Okay. And they tell us that the angle of depression. So angle of depression is the horizontal angle that he forms with himself and then whatever the diagonal is. So that's 62 degrees. Okay. The nice thing is the angle of depression is the same as the angle of elevation, which is also 62 degrees. So what I'm looking for is the height then. He is off the ground. So height is opposite over this is the opposite. I'm jumping ahead here, sorry. The hypotenuse is 200. Opposite over hypotenuse, that ends up being for us then sine, because sine is opposite over hypotenuse. So the sine of 62 degrees is h over 200. Okay, so multiply by 200, 200, and then we get 200 times the sine of 62 degrees equals h. So go to the calculator. 200 times the sine of 62 degrees gives us 176.6 feet. There's the exact, there's the approximate. Okay, now the last problem I'm going to look at is number 3. It's the last one we looked at in class. Okay, so talking about a water tower. So again, if you can't read this, this is number 3 from a worksheet we did in class, so you have to come in and see me. So a student can see a water tower from the closest point of the soccer field at San Lobos High School. The edge of the soccer field is about 110 feet from the water tower, and the water tower stands at a height of 32.5 feet. What is the elevation of if the eye level of the student viewing the tower from the edge of the soccer field is 6 feet above the ground, round to the nearest tenth. Okay, so we have to draw this first. So here is our water tower, say, whatever water tower, and then it's 110 feet from where he's standing at in the soccer field. Okay. Now the tower itself is 32.5 feet. But, and here's the key, what is the angle of elevation if the eye level, okay, we're looking at an eye level of the student is 6 feet above the ground. Now obviously this is not to scale, but this is what we're saying here. Okay, I know it's 110 feet here. Okay, this is 6 feet short of 32.5 feet. So actually the length we're looking for here is 32.5 minus 6, which is 26.5 feet. Okay. So now if I take that triangle and sketch it off to the side, just the triangle itself, I get this. There's our angle theta. This is 26.5. This is 110. So I'm doing opposite over adjacent, so that's tangent of the angle is 26.5 over 110. So if I want to solve for the angle, then that's when we use that inverse tangent. Okay. So in order to do that, I go get the calculator out, move it over here. On second tangent, that's what we're doing because it's inverse tangent. 26.5 divided by 110. And it's 13.5 degrees because it did say nearest tenth of a degree. Okay, there we go. That's section 8.5.